December 2013, question 5, is called an equilateral triangle. That's a triangle where all of the sides are equal and therefore all of the angles are equal. And it says, what is the perimeter of an equilateral triangle with side length 6? So that's just 6 plus 6 plus 6, 3 times 6, 18. You'll notice I've written units there. It doesn't specify that it's centimeters or meters, so I've just called them units. Question 5.2, what is the area of an equilateral triangle with side length 6? Well, to work out the area of a triangle, you need the base and the height, because the area is a half times the base times the height. So to work out the height, I've drawn a line down the middle and split the triangle into two. Because I've split it in two, I know that's going to be 3 at the bottom, half of 6. And I'm going to use Pythagoras. The height squared plus the 3 squared in one of these right-angled triangles makes the 6 squared. So you've got a right-angled triangle that's formed when you drop a line down, and the two smallest squares add up to the square of the largest one. So having figured out that it's Pythagoras, I can now figure out the height. So that's height squared plus 9 equals 36. Take away the 9 from both sides, I get that the height squared is 27. So the height itself must be the square root of 27. And that's about 5.2. So the height is about 5.2. And now we can work out the area. So the area is half times the base times the height. So 0.5 for a half times the base, which is 6, times the height, which is that expression there, which is the 5.2. So that comes to about 15.6, and again I've called them square units rather than centimeters squared because it doesn't specify anywhere in the question that the units are centimeters or otherwise. Now I used Pythagoras here, but there could be marks available for just figuring out that height from a neat diagram, because later on in the question they seem to ask you to do the same thing again, figure out that missing side. So perhaps they were expecting you to just do it from a scale diagram in this part of the question. Okay, moving on. A median in an equilateral triangle splits the triangle into two congruent, that means that they're the same shape and size, right-angled triangles. See, that's what I just did to work out the height. In questions 5.3 to 6, you have to investigate one of the right-angled triangles. How many degrees are there in each angle of one of the right-angled triangles? Okay, so you've got a straight line that's been split down the middle, so 180 divided by 2 gives you 90 in the middle there. Also, they've told you it's 90 by putting that little mark there. The second angle is 180 divided by 3, which is 60. That's because a whole triangle adds up to 180. All of the angles are the same in the big equilateral triangle. So one of them must be 180 divided by 3, which is 60. And then the angle at the top, which I've called the third angle, it's the 60 divided by 2 because it's been split down the middle to make 30. So 90, 60 and 30, with some kind of calculation or justification as to how you got there. 5.4, explain why the hypotenuse is twice as much as the shortest side. Okay, so explain why the hypotenuse, that's this side here, which was one of the sides of the right-angled triangle, of the equilateral triangle, I should say. Explain why that is double this length at the bottom. So I've put the sides in the original triangle were the same, were equal, because it was an equilateral triangle. The hypotenuse was one of those three original sides. And the shortest side in the right-angled triangle is half of one of the original sides. So the hypotenuse is twice that shortest side. There's probably a better way to explain that. 5.5. How big is the shortest side, the longest side, when the hypotenuse is 6? Okay, so the hypotenuse is 6. We're just looking at the yellow bit there, one of the two right-angled triangles. The longest side, the hypotenuse, is 6. We know that the shortest side is half of that, which is 3. So how long is the longest side in the right-angled triangle? Well, that's what I did before when I was working out the area. And I got it to be the square root of 6 squared minus 3 squared, which was 5.2, using Pythagoras. So longest side, square root of 6 squared minus 3 squared equals 5.2 units. So you can go back to the previous part of the question if you want another look at the reasoning for the Pythagoras there. Then 5.6, Gustav claims that the length of the longest side is 0.3 times as long as the length of the shortest side. Investigate with the help of a calculation whether Gustav's claim is correct. So what I've tried to do here, I've taken the longest side, which I already worked out to be 6 squared minus 3 squared. That was all the Pythagoras stuff. Divided it by the shortest side, which was the 3, and see what I get. So that was the 6 squared minus 3 squared comes out to be 27. So we've got the square root of 27 divided by 3. Now, if you know your rules of square roots, a clever way to do this is to say that 3 is the same as the square root of 9. So we've got the square root of 27 divided by the square root of 9. And there's a rule for writing that as a simple square root. It's just the square root of 27 divided by 9, which is the square root of 3. So it is root 3 times as long. If you're not confident with those rules about square roots, you could have tried to do the same thing with decimals and show that the number of times bigger it is the decimal equivalent of the square root of 3. Don't panic about that question being a bit complicated. It is one of the harder ones, and I would say that's one of the questions for separating somebody getting a 10 from somebody getting a 12. So you need to be getting that right if you're aiming for 12, but otherwise don't spend too much of your exam time worrying about it when there are easier marks to be found. So here are my neatly lined up answers, and here are the marks for them: 3, 4, 4, 4, 4, 4. I've just noticed that they're not neatly lined up there, they should be.